Okay, let's look at a similar example to quiz 6, number 3. Right, so you have a function given right here, x times quantity x minus 3 cubed. And what we want to do is we want to first find the derivative, so let's do that. Right, so there are two things multiplied together, so x is the first guy, and the quantity x minus 3 cubed is the second guy. So let's take the derivative using the product rule. So f prime of x is equal to, right, derivative of the first is 1 times the second, so quantity x minus 3 cubed plus first guy x times derivative of the second guy, so our general power rule, 3 in front, keep the same quantity x minus 3 and raise it to the 3 minus 1 is 2 and multiply by derivative inside, which is 1, so I'm not going to write that down. Right, then we just have to clean it up a little bit. Right, so this is going to be, right, what's in common. Right, you can see that you have x minus 3 and you have 3 of them, x minus 3, 2 of them, so we can factor out 2 of them, so this guy, and I'll just circle that, so we can factor out quantity x minus 3 squared. Right, then we collect leftover term. All right, 1 really doesn't do anything, so you have x minus 3, right? Then you have plus 3x, right? Which is going to be equal to, right? You have a quantity x minus 3 squared. Then you have, let's see, x plus 3x, so you have a 4x. Then you have a minus 3, right? So this is our first derivative, right? And then we need to find the critical numbers, so we set this equal to 0. And you see that critical numbers are x equals 3, and also set this equal to 0, so that's going to be 3 over 4, 3/4. Right, so those are critical numbers. Alright, then we're going to use the first derivative test to see if 3 and 3/4 gives us a local max or local min, or it could be neither. So let's look at that. So let's do a number line. Alright, so I place up tick marks for 3/4, and then you have a 3. Right, then we look at the sign of the first derivative. Right, we know that the first derivative is 0 here, and 0 at x equals 3 as well. Right, so let's try something smaller than 3/4. So I'll probably try something like 0. Right, so if you plug in 0, this part is always positive. Right, so we don't have to worry about that. But if you plug in 0, it's going to be negative. So you have a negative sign here. Right, and between 3/4 and the 3, so I'll probably try x equals 1. Right, so if you have 1, 4 minus 3 is positive. Right, positive times positive is positive, so you have a positive sign here. Right, after 3, so like x equals 4, and you see that 4 times 4 is 60 minus 3 is positive, so everyone's positive, so it's still positive. Right, by first derivative test, so we have to use that. we know that, let's say, decreasing turned into increasing, so we're going to have local minimum at 3/4. And here, increasing turned into increasing, so this is going to be neither. Right? So first derivative test, we know that f has a relative minimum at x equals 3/4, right? But has a neither at x equals 3, right? So that's the answer for part B, right? Alright, so how about part C? Find an open interval on which f is concave downward. So we're going to have to take another derivative. So we're going to look at the second derivative. So f double prime of x is equal to, so we're going to take the derivative of that. So this is our first guy, this is our second guy, then use the product rule to take the derivative. So derivative of the first guy is 2, keep the same quantity x minus 3 to the first power times derivative in size is 1, so I'm not going to write that down, times the second guy, which is 4x minus 3, plus first guy, quantity x minus 3 squared, times derivative of the second, which is 4. Right? So you can see that, let's see, there's 2 here, so 4 is 2 times 2. So I'm going to actually write 4 as 2 times 2. Right? So this way, so we can factor out 2 here. Right? So pull that out. So that's a common factor. Right? And also x minus 3 here, there are 2 of them, so I'll take one of them. So quantity x minus 3, right? And then what's left is you have 4x minus 3 from the first term. Then you would have to distribute 2 to x, so that will be positive 2x, right? Then you have to distribute 2 to negative 3. So it's negative 6, right? So you will get this is equal to 2x minus 3, right? I'm going to actually simplify this. So this is 6x minus 3 minus 9, right? So actually I'm going to pull out 3 from there because 6 has 3, 9 has 3. So this make it 6, 2 times 3. Right, so 3 is factored out, so 2x and a minus 3. Right, so we're gonna take set that equal to 0. So to get x equals 3 is one of them, and it's going to set this guy equal to 0. You have 3 halves. Right, so let's do a number line on this. Right, so 2 tick marks for 3 halves, so that's 1.5 and a 3. Right, then we look at the sign of the second derivative. Right, so we know that the derivative, second derivative is 0 here and 0 there. Right, try anything smaller than 3 halves, so I'll try 0. So you can see that this is going to be negative, this is going to be negative. So which means that this is positive. Any number between 1.5 and 3, so I'll probably try 2. Right, 2 minus 3 is still negative. 2 times 2, 4 minus 3 is positive, so this is negative here. right? So we try something bigger than 3, so I'll try 4, right? 4 minus 3 is positive. 4 times 2, 8 minus 3 is positive, so everything is positive here. So original function, right, second derivative positive means that that's going to be a concave upward here. This means that the concave downward, and the second derivative positive, concave upward. So to answer question, we're looking for the open interval where it's a concave downward. So we're looking at the interval from 3/2 to 3, right? So therefore, answer would be f is concave downward on the interval from 3/2 to 3, right? So this is the answer for part C. Alright, that's it. I hope that this was clear.